Okay, in this presentation we're going to look at a complex numbers problem. So we have three complex numbers here, z1, z2 and z3. z1 is 2 plus 3i, z2 is 3 plus 2i, and z3 is a plus bi. Okay, so we have to, essentially we're probably going to have to figure out what a and b is. In the question we are told that they are real numbers, so that is actually important. They are real. Okay, that helps us later on, or could help us later on. The first question is simple enough. It asks us to find the magnitude of z1 plus z2, and essentially what we do there is just add them both. 2 plus 3 gives us 5. 3i plus 2i gives us 5i. Working that out, 5 squared, so essentially you square this term here, and we add them together and we get the square root of that. So we get 5 squared plus 5 squared, that is 25 plus 25. The square, and we get the square root of that, those two numbers added together. So that is square root of 50, and if you want you can just break it down a little bit further to say 5 times the square root of 2. Okay, that's part A. That's straightforward enough. Part B is a bit more complicated. We're given this expression here as w, and we're told that it is equal to z1 times z3 divided by z2. So this is a good bit more work here. Okay, what we're asked to do is actually find it in terms of a plus bi. Okay, now that'll actually keep that in mind because it sort of might help us speed things up. That is like how we're expected to phrase the question. Okay, so essentially what we are going to do is we will focus on this part first. Okay, essentially what we'll do is where we have the numbers, that we know the numbers, we'll treat that as one part of the question, and essentially what we'll do is treat a plus b as the sort of second term. Okay, so what I'm going to do here is sort that one out by using the complex conjugate here. So that's the complex conjugate of 3 plus 2i. Okay, so multiply above and below by the complex conjugate. Okay, and later on we'll come back to this a plus bi. So when we multiply by the complex conjugate, we get 9 plus, sorry, that should be just plus 4 there. 9 plus 4, that's 3 squared plus 2 squared, essentially. So that'll end up as 13. Okay, and multiplying the numerators, 2 plus 3i times 3 minus 2i, we'll get 6 minus 4i plus 9i plus 6, and when we work that out, we should get, oh sorry, just to be clear, the plus 6 is minus 6i squared. Okay, so I should have just mentioned that. Okay, we'll run into that very quickly. But that's the minus 6i squared, which is plus 6. So that works out to be 12 plus 5i over 13. Okay, and now what we'll do is multiply that by a plus bi. I'll just take out this 13 out of it. Okay, so just have it 1 over 13, and multiply this expression here by this expression here. And again, just keep an eye out for the I squared terms. Sorry, my video just jumped there for a second. So 12a plus 5a squared, sorry, 5ai, okay, plus 12bi plus 5bi squared, which is minus 5b. So essentially what we do is bundle them up there, and that's the real, and that is the imaginary part there. So it's not particularly neat, but that is, that is the answer we're looking for. Okay, now we're told in part C that that is equal to 17 over 13 minus 7 over 13 times I. Okay, so essentially what we have to do there is just figure out the values for A and B. So necessarily this is, that part there is equal to 17 over 13. Okay, so essentially what I'm going to do there is just focus on the numerator and say that 12a plus minus 5b is equal to 17. And similarly for the the imaginary part there, 5a plus 12b, that must equal to 7. Okay, because again, the denominator in both cases is 13. So we won't be worrying about the 13. We'll just sort of say, we'll look at the two numerators. Okay, so 5a plus 12b minus 7 and 12a minus 5b equals 17. What's a and b? Essentially what I'm going to do here is multiply both sides. I'm just going to pick one of them there, and I'm just going to multiply that expression there by 12 and that expression there by 5. Okay, so I end up with these. So rephrasing those two equations as 144a minus 60b equals 204. That's 17 times 12. 25a plus 60b equals minus 35. Essentially what I do is add up both equations. Just add up all the terms. So 144 plus 25a, 144a times 25a equals 169a. That cancels out to 0. And also 204 minus 35, that also is 169. So necessarily a is equal to 1. And that means b will have to be equal to minus 1. You can just sort of check that yourself. 12 times 1 minus 5b is equal to 17. That means minus 5b is equal to 5. That means b has to be equal to minus 1. Okay. So the last part here is find the argument of w. Okay. Now this is important here because you have to sort of check where you are on the Argand diagram. Okay. So essentially just on your plot there, just actually be very careful about which quadrant you're in. Okay. So you're actually in this quadrant down here. Okay. Now that's important because you have to sort of choose your sign. You have to do the calculation first off. It's a bit of calculator work, but the real trick is making sure that you have you're in the proper quadrant. Okay, so it's essentially minus 7 over 13 being it's from the axis. It's minus 7 over 13 down. Okay, anyway. To find what the raw value of theta, okay, you just get tan of minus 1 over the real, or the imaginary divided by the real, and, 7 over 17, bit of calculator work, that would work out to be, to 3 decimal places, 0.391, okay. Now, because it's in this quadrant here, at this particular point here, that actually should be a negative number. If you left it alone and just reported it as 0.391 and you forgot to do the sign part, you're really referring to this point here, this number here, okay? If you're trying to remember what should be positive and what should be negative, just remember the ACTS acronym. So ACTS. So essentially everything in this quadrant should be positive, but only in this quadrant only cosine should be positive, and essentially everything else should be negative. So essentially what we should have here is a negative tangent value for the tan. So that is why we get a negative there. Okay. So this ACTS thing from trigonometry, and again it's just actually how to sort of remember what should be positive and what should be negative. That is very useful there. Okay. Right, we'll leave it there.